And wireless communication, the fifth unit is MIMO. What is MIMO? That is the multi-input, multi-output system. Multi-input, multi-output system compromise of antenna elements and adaptive signal procedures, both the transmitter and receiver. At the transmitter, encoding, modulation, mapping procedure takes place before the signal is transmitted, whereas at the receiver end, the reverse process takes place. At the receiver, demapping, demodulation, decoding are done recover the signal. MIMO system are multiple input, multiple output system with many antennas. This is the transmission system of MIMO. So you will see then that the block diagram is the benefits of multiple antenna technique. That is the spatial diversity technique, diversity gain, multiplexing gain. In wireless communication, the multi-input, multi-output system offers high data rates and lower error rates. A balance is struck between power efficiency and spectral efficiency. The transmitter and receiver units operate in time or frequency domain. The principle of using multiple antenna at transmitter end or transmitter end is unknown. In MIMO, there are some schemes are there. One is the MIMO, multi-input, multi-output. Second one is the SAMO, that is the single input, multi-output. And the third one is MISO, that is the multiple input, single output. In addition to that, a time and frequency domain, spatial domain can also be used. A trade-off between power efficiency and spectral efficiency is achieved in MIMO system and is used in wireless transmissions. Diversity gain mitigates the padding and increase coverage and improve units. Multiplexing gain increases capacity and spectral efficiency with no additional power or bandwidth expenditure. Array gain results an increase in average received signal to noise ratio. Spatial diversity and spatial multiplexing can be conflicting. What are the advantages of your MIMO system? That is reduced error rate, higher capacity, better transmission quality, high coverage capacity, increased data rates, better user position estimates. These advantages are possible due to spatial multiplexing gain, array gain, diversity gain, and reduction in interference. The capacity of MIMO systems is proportional to minimum number of transmitter and receiver antennas in the system. So this is the structure of your MIMO system. There are many transmitter as well as the many receiver. There is a channel in between transmitter and receiver. That the simple MIMO system is shown in figure. In this system, assume there are many transmitters and many receiver antennas that are available, where the number of transmit and receive antennas may vary as single or many. In a MIMO system, it is very useful in wireless communication. The use of multiple antennas both at transmitter and receiver ends. The MIMO model applies space-time coding, allometric coding schemes in its transmission and transmission efficiencies. This coding is independent of channel state information at the transmitter. And the next one is spatial multiplexing. Multiplexing is transmitting message from one or more transmitter to one or more receiver from over the same medium. There are many domains of multiplexing available in radio system, include space, time, frequency, phase, and area. In space diffusion multiplexing (SDM), it propagates signal from different sources within the same medium. That the basic concept of multiplexing is to divide or multiplex a data stream into branches and transmitting them through several independent channels. What is the characteristics of your SDMA? It requires no bandwidth expansion. It needs space-time equalization in receiver. Data streams can be separated by equalizer. It is better alternative approach to spatial diversity. Independent and spatial channels give accurate results in transmission. So this is the spatial multiplexing technique that will be used from block diagram and layered spatial structures. In spatial multiplexing, several different type of data bits are transmitted through many independent spatial channels. The input channel signal to be transmitted is sent through antenna elements as branches in wireless radio. The signal received via a receiver antenna elements. This is the feedback taken and of feedback to transmitter for further analysis that the received signal is taken as output from receiver. The linear dispersion coding (LDC) method combines the spatial multiplexing with transmit diversity. The first layered space-time architecture for the first space multiplexing system offered by Bulb Labs. It is also meant as layered space-time, it is LST. The serial to parallel conversion is done in shown in figure. The input signal is given to layered branches, say 1 to up to n. The modulation and coding signal are then and given to modular MMM and then transmitted through antenna elements 1 to m. The data strings 1 to n is transmitted in spatial structure. At the receiver end is spreading, demapping and dematch procedure are done. How we define a system model? Okay, in multiple antenna technique, consider M transmit antenna and as N receive antenna. Assumptions remain non-selective fading, no ISL effects. Relay fading with no line of sight components. Block fading taking place and the channel gains are invariant over the entire data block that would change randomly from one block to next block. The channel matrix in the model is denoted by a X, H, and it is denoted by this matrix. Next topic is precoding. In multi-user MIMO systems, it provides high capacity with space division multiple access. The channel state information, if available at base station or access point AP and multi-user information LBUI can be supplemented. Precoding allows to perform many complex processing at BS to BS or otherwise AP. It helps simplification at user's end. The linear precoding technique reduces computational complexities when compared to nonlinear technique. But nonlinear technique yields better performance. MIMO technique gives performance and bandwidth efficiency. In download, the BSR and AP is provided with multiple antennas and transmit to a group of mobile users simultaneously. The precoding used in MIMO are classified in the amount of multi-user interference that they are allowing. Compared to linear precoding and non-linear precoding techniques provides higher capacity. So that the first one, black diagonalization technique, BDT, is one of the linear precoding technique used for downlink curve your multi-user MIMO system. The information signal is pre-processed at transmitter with a modulation matrix which lies in the null space of other subscribers channels matrices in the transmission. Hence, the multi-user interference is set 0 in the system that the BDT will be efficient if the subscribers are equipped with more than one antenna. Another precoding technique is known as successive optimization technique, SOT. It helps the power minimization in addressing near and far problems. But the factors that would influence the performance of SOT are power allocation and the order of pre-processing and subscribers signals. With BDT, There will be capacity loss due to nullifying overlapping subspaces of different subscribers. The SOT method precoding is an alternative applied for achieving better power control, and SOT reduce the capacity loss, but there might be some interference. In nonlinear precoding, there are few nonlinear precoding techniques such as Tomlinson-Hashima technique. THT is developed in SISO channel. It is also recommended for equalization of MUI in the MOMO system also. The minimum mean square error MMSCT technique is another precoding technique and is applied in combination with THT precoding principle. It helps to balance MUI and reduce the performance losses to some extent in MOMO system.